So to begin, we are going to be solving word problems using substitution today in this video. However, as a refresher, why don't we just practice the procedure of solving by substitution? So if you look at this problem, it says Emily solved the system, and there is a system by substitution. She said her answer is -4, -1. Is she correct? And if not, we need to correct her error. So first, let's go ahead and plug in this value into our system and see if it's right or not. So if we plug in y is -1 and x is -4, do we get the right answer? We get -1 equals 4 plus 3, -1 equals 7. Okay, we know that is not correct. So her answer is wrong. Now let's figure out how we could solve this correctly. And so why don't we use substitution? And so I got one of my variables all by itself. Now if y equals the opposite of x plus 3, everywhere I see a y, I'm going to put the opposite of x plus 3. So then my problem is going to be the opposite of x plus 3 equals -2x minus 1. Now I need to solve for x because notice I only have a single variable. I only have x's, so I did my substitution correct. So I'm going to add 2x on both sides. And I get x plus 3 equals -1 minus 3 on both sides, and x equals -4. Oh, interesting. So she got the x correct. That means she must have just screwed up with the y value. So let's plug that in to the first equation and solve for y. Y equals the opposite of x plus 3. We know the opposite of x is -4. So y equals the opposite of -4 plus 3. Y equals 4 plus 3, so y equals 7. However, before we can be confident in our answer, which we currently think is -4, 7, we should definitely check our answer because she must not have checked, and that's probably why she got her answer wrong. So let's see. If y is 7, does that equal the opposite of -4 plus 3? Well, yes, that would be 7. And if y is 7, is that -2 times -4 minus 1? Well, -2 times -4 is 8. 8 minus 1 is 7. So yes. So because we actually went through and did that next step of checking our answer, we can be confident that our solution truly is -4, 7. Now, just like what we did on the first slide in that warm-up, when we solved by substitution, we're going to do the same thing today, except now we have a word problem. And so steps 4 and 5 are going to be that procedure part that we did yesterday, and then that first word problem. But steps 1, 2, and 3 are what is introduced when you deal with a word problem. So first, in step 1, it says to identify important information. So as we read this, I'm going to highlight things that sound important. A hairdresser finds that he can give 3 haircuts, that sounds important, and 2 hair dyes in 315 minutes. If he gives 2 haircuts and 4 hair dyes, it takes 450 minutes. And the question is asking how long does it take to give a haircut, and how long does it take to dye a customer's hair? And so remember, step 2, after we read our problem and figure out what's important, we have to define our variables. And remember, I said when we define our variables, we write that let statement. So let x equals, let y equals. X and y are going to be our unknowns. Because remember, a variable is something that's unknown. So we have to think about what don't we know. We don't know how long it takes to give a haircut. So x is going to be the minutes to give a haircut, because that's something we don't know. We also don't know how long it takes to dye a customer hair. So y is going to be our minutes to give a hair dye. Because remember, those are things we don't know, so those have to be our variables. And then step 3, we have to write a system of equations. And so I'm going to make my curly brackets. And so from my highlighted information, I have to write a system of equations. It says 3 haircuts and 2 hair dyes takes 315 minutes. 315 is a total, so I'm going to have something equals that 315. And it's going to be 3 haircuts at X minutes and 2 hair dyes at Y minutes takes 315 minutes. Similar with the second statement, 2 haircuts at X minutes and 4 hair dyes at Y minutes take a total of 450 minutes. And so right there we have our system. From here, we now need to solve using substitution, because that's what next. Solve the system by substitution. And so that goes back into that procedure portion, like we did on the first slide. And then if you went and solved our system that we had come up with, you'll see that y is 90, x gives you 45, and then in the end, because it's a story problem, you need to label your answer. So it takes 45 minutes for a haircut and 90 minutes for a hair dye. Here's another example with a word problem. So Jay has written 24 songs to date. He writes an average of 6 songs per year. Laura started writing songs this year and expects to write about 12 songs a year. How many years from now will Laura have written as many songs as Jay? So, just like last time, we first want to go through and identify what's important. So Jay has 24 songs, and he writes 6 songs per year. Laura just started writing and expects to write about 12 songs per year. And it's asking, how many years from now will Laura have written as many songs as Jay? And so when we write this let statement, let x equal and let y equal, just because we're already down to number 2, which is defining, we have to think about what don't we know and what do we need to find. How many years from now will Laura have written as many songs as Jay? So if x is our number of songs, then y is going to be the number of years. Years from now.
Does Shariah come to you right away?
Now that we've done steps 1 and 2, we're down to step 3, where we have to write that system of equations. So remember, it's challenging for now, but the more we practice, the easier it will get. Looking at Jay, we know he has 24 songs currently, and he writes 6 songs a year. So, if we add it all together, we would get our number of years, or number of songs, which would be the 24 songs he currently has, plus his 6 songs every year. Now thinking about Laura, she writes songs this year, so she has none written already. And she plans on writing 6 songs per year. Or 12 songs, sorry. She plans on writing 12 songs per year, and that will be her total number of songs. Now from here, we need to solve. And we're going to solve by substitution, because that's what we're working with right now. So step 4, solve by substitution, list, label, and check your solution. So go ahead and solve this on your own, and then come back and let's see if you got it right. So looking over the answer, we had our system. I solved for one variable, and I wrote my equation. And at this stage, I notice I only have y's, and I solved, and then I solved for my x's over here. I checked my work down in the bottom corner, and then I highlighted my answer. And notice how I worded my answer. I didn't just write an ordered pair of 48, 4. That doesn't make sense. But what it's really meaning is that in 4 years from now, they will both have 48 songs. And the question is actually only asking, how many years from now will they have written as many songs as each other? So really what we care about is this beginning part. We really only care that they will be at the same spot in 4 years.